All right, I want to go over the midterm exam. We'll start with question number 1. We've got a $4 million par March 20th T-bill. The dealer is going to sell. So the dealer will sell at the ask price. And the formula is going to look like this. The price is equal to the face value, the $4 million, times 1 minus the number of days to maturity, and I'll explain that in a second, 23, times the bank discount yield, which is 0.00015, divided by 360, and that's equal to this number here. Now note, these bank discount yields are quoted in percentage, so that's why I moved the decimal place over to. The number of days is 23 because today's the 25th, so it's 2 days to the 27th. These mature on Thursday, so I know they're 7 days apart, so that's 9, 16, 23 days. Alright, so for the bond equivalent yield, ROI is going to be equal to 365 times the bank discount yield, which is 0.00015, divided by 360 minus the number of days, 23, times the bank discount yield again. So that would be 0.0152%. Alright, now let's move to problems 3, 4, and 5. Ignore the numbering here. Alright, so the clean price of the April 15th security, assuming a retail investor is selling, if you're going to sell, you're going to sell at the lower price. So it would be right here. And I'm assuming $1,000 par. If you didn't do that, that's fine, but it's 100.156% of par. So if it's $1,000 par, then it's going to be this right here. Okay, so the accrued interest for the May 15th security, let's draw this timeline over here. Let me do this in a different color for you. So the May 15th 2014, we'll pay May 15th 2014. Today is 2/25/2014. This last paid 11/15/2013. So I need to figure out the number of days in this period right here. So I'll do it in this color. We have 15 days left in November, 31 days in December, 31 days in January, 25 days in February. Add all that up, that's going to add up to 102. And then if I'm looking at the entire period through here, I have 15 days in November, December, January, February, March, April, May. So I add that up. See, that will be 181. So my accrued interest, because it's a 1% coupon, that's $10, but pays twice a year, so that's a $5 payment. But you deserve 102 days worth out of 181 days. That rounds to $2.82. Alright, so let's go to this one right here, and we'll draw a timeline again. And let's see, today is 2/25/14. It's going to mature May in 2015, so it last paid November 30th 2013. It will pay again May 31st 2014, then November 30th 2014, and then May 31st 2015. It will pay $40, $40, and 1,040 because it's an 8% coupon. So I know the price is going to be equal to 40 divided by 1.0405 to some power, because it's an 8.1% yield to maturity, semi-annual pay, so I divide that by 2. Let's leave the power alone for now. I might have this 40 divided by 1.0405, that raised to some power, and 1,040 divided by 1.0405, that raised to some power. Now the question is exactly what should that power be? Well, I don't have this for an entire period, right? And I have, oops, that's not what I wanted to do. I want to know how many days there are to the next payment. So let's calculate the number of days to the next payment. And hang on, let me erase some of this stuff. Okay, so we have, let's see how much is in the total period here. I have December, January, February, March, April, May. I add that up and that's going to be 182 days. And how many days from February to May? I got 3 days left in February. I got March, I got April, and I got May. That adds up to 95. So I need to raise this to the power of 95 over 182. Let's just say V is equal to 95 over 182. Whatever that comes out to be is 0.52 or something. So this would be 1 plus V. That would be 2 plus V. And then this should equal 1,017.75. So here's the key part of it. I'm going to erase this and put V right there. I do the exact same thing. The price of any financial asset is the present value of the expected future cash flows. I know the expected future cash flows. I know the discount rate, but the timing is a little different. So it's not one period from February to May. It's a partial period. Well, exactly what partial period? It's 95 days out of 182 days in a normal period. But from May to November and November back to May, that's a full period again. So I raise it to those powers. Alright, so let me go to the next problems here. Okay, questions 6 through 9, and it's not 1, 2, 3, 4. I just have some problem when I'm copying and pasting the numbers here, so just ignore that. Alright, what is the 18-month spot rate? The way I want to do that is the following. I know the price of any financial assets, the present value of expected future cash flows. So 101 is equal to, and it gives me, that's the price, right? The cash flows are 2.5. 2.5 because it's 5% divided by 2. And 102.5 because this is for 3 periods. I discount the first rate at 1 plus 0.0101 to the first because that's Z1. And then 1.0154 squared because that's Z2, and then 1 plus Z3 cubed. I'm not going to do the algebra. Z3 is equal to 0.02172. So the interest rate, the spot rate, R3, is going to be the 2.172% times 2 to annualize it. For the 2-year spot rate, it's going to be very similar. I'm going to have 98% of par. 98% equals, there's a 4% coupon, so that's 2, 2, 2, and 102. Those are the cash flows. Now, how do I discount them? 1.0101 to the first, 1.0154 squared, because that's Z1 and Z2, right? And then 1.02172 cubed, because that's Z3. By the way, those are all 2's and not Z's, of course. And this is going to be 1 plus Z4 to the fourth. And if you do the algebra right, you'll find Z4 is equal to 0.02556. So, of course, R4 is 2.556% times 2. Okay, what's the price of a 2-year semi-annual pay bond with a 7% coupon? Let's try that in just a different color here. The price of any financial assets, the present value of the future expected cash flows. Those cash flows are 35, 35, 35, and 1,035 because it's 7% divided by 2. And then I discounted Z1 and Z2 squared and Z3 cubed and Z4 to the fourth. And that should equal 1037.02. And now if I want to find the yield to maturity, n is equal to 4, because the yield to maturity, by the way, is whatever y, 1 plus y in here. That's an ugly y, so it's going to be all the same. So rather than discounting it at 4 separate rates, it's just what's, in a sense, what's the average of those weights, and kind of weighted by time and dollars. So the payout rule of the bond is 4 payments of $35 each. The future value is $1,000. The present value, and I gotta make it negative to make a calculator happy, is 1,037.02. I plug this in, and it gives me an interest rate. But this interest rate is going to be a semi-annual rate, right? Because this is 4 semi-annual periods. So whatever that rate is times 2 is going to be equal to my yield maturity of 5.03%. Alright, I'm going to stop there. This will be the first part of the midterm.